Welcome to the Stormsurf Videos Surf Forecast for the week starting Sunday, October 16th. Looking at significant wave heights for the North Pacific Ocean, we see a gale off of Northern California producing 20-foot seas and a broader area of 18-foot seas. These seas are moving to the east and poised to start impacting the California coast by Monday. There's another gale off of the northern Kuril Islands, producing 22-foot seas, pushing towards the dateline, but not much is expected from it. Small swell might result for Hawaii. And there is a tropical system, Haima, 25, pushing to the west with 95-knot winds, expected to impact the northern Philippines in a day or two. We'll start this week's tour by taking a look at jet stream level winds. These winds, up about 30,000 feet, help support the formation of gales. When those gales do form, help direct their track. We're looking for a dip in the jet. That is a trough, like right there and like right there. These dips help support counterclockwise flow aloft and down at the surface. That is the hallmark, actually, of low pressure. And low pressure, of course, generates wind. Winds generate seas. Seas generate swell that, when they radiate away from the fetch area, eventually create surf. Anyway, we have a small trough here. Not a lot of wind. This is over the northwest Pacific. Not a lot of wind supporting it, though. Only 100-knot winds. Not lots of energy, but we did see in the previous chart there is a little bit of a low here and some seas developing. There is a much stronger flow here, 150-knot winds from the dateline falling into a gentle trough off the U.S. West Coast. This trough has been in place for a couple of days now and has generated a series of gales and wind and rain and swell pushing into California. One more looks likely. This as of 18Z Sunday, and that should set up swell for the weekend. For early next week. Anyway, we looked, the jet stream pattern gets a bit weaker as we move into Monday night. Still, this sort of a general trough off the U.S. West Coast, but that quickly fades. Another trough is supposed to set up here in the northwestern Gulf on Tuesday. There is some suggestion that it too could develop a little bit. Notice this south sinking winds here. That would definitely support gale development, even though they're not strong. A lot of times the motion makes up for lack of wind speed. Then we get this sort of a cutoff trough north of Hawaii on Thursday. There's some suggestion that perhaps this trough too could help develop something down at the surface. And then yet another trough come Friday developing over the Kuril Islands, pushing off of Kamchatka. Not a lot of wind speeds associated with it, and maybe some development from that. But notice the jet stream now, by the time we get into Saturday, sort of a trough here over the northwest Pacific, a big ridge, another trough in the east Pacific, but not much energy, kind of fragmented, a little bit of a split here, a little bit of a split here, and just not quite as cohesive as it was. Anyway, this pattern is to persist into Sunday and then even into Monday. A little bit more wind energy is suggested developing over Japan at that time, and the jet becoming a little bit more cohesive. It's unclear what effect the MJO, the Madden-Julian oscillation, is having on the jet stream pattern. Typically what happens when the jet gets really organized, like what it has been the past week or two, that is because the Madden-Julian oscillation is in the active phase, or at least moves out of the inactive phase and sort of feeds fuel to the machine. That doesn't seem to be the case, but we'll get into that more in a couple of minutes. Next up, let's take a look at surface level wind, surface level pressure. And as expected, low pressure is in fact in the eastern Gulf of Alaska, generating a broad fetch. Here's a pocket of 30-knot winds here, another pocket here, and this is what's generating the 20-foot seas off the California coast. Also, much lesser period wind swell intermixed with whatever swell is being generated. Also, we did see a dip in the jet here over the northwest Pacific. That is generating a small area of 40-knot winds, and we saw seas in this area. And then our tropical system off the Philippines moving to the west. Otherwise, not a whole lot happening. We roll this out, and into even Monday, fetch remains in the Gulf. The system that was in the West Pacific starts falling apart and dissipating. And then we get into Tuesday, and notice low pressure starts developing here in the Gulf of Alaska. High pressure over the dateline. The difference in pressure and the tightness of the isobars between the two should start to generate some fetch. In fact, we'll roll this up. You see low pressure building up into Tuesday night, And then into Wednesday, you get this south-sinking 40-knot fetch. Again, the high and the low in pretty close proximity, generating fetch aimed generally at the California coast, maybe sidebands fetch at Hawaii, but not really. Also notice the tropical system moving inland. Roll this out, and the low keeps developing, falling east. That should generate swell if it actually verifies. And then more low pressure starts developing here off the coast of the Kuril Islands. Pretty strong winds, but most of that's all behind land, 55-knot winds. And it isn't until Friday that it finally tries to make headway away from being landlocked, but then it quickly falls apart. Perhaps some little swell could result for Hawaii. Also notice this bit of a low here, generating barely 30-knot winds, but that's good for some north wind swell, perhaps for the Hawaiian Islands if it plays out. And then we get into 180 hours out. Notice a lot of high pressure here over the Gulf of Alaska and even to the dateline. That might block things off for a while, but we'll see. And then finally, let's see the effects of those winds on the ocean surface. As we saw before, 20-foot seas developing off of Northern California right now, 18Z on Sunday. Those seas sort of fade, and by Monday morning, they're below the 18-knot threshold, but they're also impacting the California coast. Some swell should result, with additional 20-foot seas developing in the northwestern Gulf, falling southeast and starting to fade. The tropical system, of course, moving off to the west. Then we get into the next swell opportunity is into Wednesday night. We see, again, low pressure, northwestern Gulf, falling south, seas pushing to, 26, 28 feet, 30 feet by Thursday morning in the central Gulf of Alaska, aimed well towards the Pacific Northwest and down through central California. Some swell should result for that, especially with that system moving off to the east. Pacific Northwest should get a good burst of swell. Next up, that moves inland. The next system develops off of the Kuril Islands, 30-foot seas on Friday night into Saturday, falling apart pretty quickly. Some swell possible for the Hawaiian Islands from that. And then actually you can see this here, remnants of the tropical system that pushed inland over here are actually supposed to start moving out off of Japan on Sunday, a week out. Probably not a whole lot of development forecast from that. Still, it looks like a little bit of swell is possible for mainly the U.S. West Coast and lesser energy for Hawaii. Just for fun, we'll take a look at the southern Pacific Ocean. Not a whole lot forecast here. It's late in the season. A tiny area, 26-foot seas forecast Tuesday, pushing to the northeast. Good for Tahiti getting some swell, but that's probably about it. And we'll just roll through this, and you see nothing else really of interest going on into 180 hours out. And one would not expect a whole lot given the time of year. So let's take a look long term, see what's going on, see what forces are in play in the atmosphere that would help affect the pattern long term as we get into fall and into winter. And the first thing we always look for is the presence of the active phase of the Madden-Julian Oscillation. The Madden-Julian Oscillation, when in the active phase, helps support storm development, mainly in winter months, but also in summer months in the southern hemisphere. The MJO typically is in play or has its greatest effect in the Pacific Ocean when it's over this area from about 135 east out to the dateline, a little bit beyond that 170 west, 5 degrees north and south of the equator. And what happens is when the active phase of the MJO is in play, it typically is in play for about 4 to 6 weeks as it works its way across the Pacific, and then the inactive phase comes in and has the same effect for 4 to 6 weeks across the same area of the Pacific. But it's mainly this area here when winds, now here's actual wind speeds from buoys on the ocean surface, all trades, all easterly, pretty brisk, but notice they're weaker here in the Kelvin wave generation area. That's what we call this, because this is also where not only it helps affect storm development, but also is where Kelvin waves are created. Kelvin waves are pockets of warm water that flow under the equator during El Nino years or the buildup to El Nino years, and that is due to a reversal or breakdown in trades in this area. So when trades lighten up, that sort of is the fuel that lights up not only the upper atmosphere but subsurface ocean-wise and helps set up changes. Now we don't see any of that scheduled to occur, but we do notice that winds are light anomalies. Differences in normal for this time of year suggest a pretty normal pattern here, and pretty normal over the Kelvin wave generation area as well. Here's another way to look at wind speeds, that is deviations from normal from this time of year in the Kelvin wave generation area. Here's the dateline. So Kelvin wave generation area is from about here over to about here or so. This is the West Pacific. This is the entire planet from 5 north to 5 south on the equator. Zonal wind anomalies, that is whether they're stronger than normal from the east or stronger than normal from the west. East, these blues and purples suggest stronger than normal trades, which would suggest the inactive phase of the MJO, and if over a longer period of time, La Nina. And clearly we see that trades have been enhanced over the Kelvin wave generation area for, well, all of September into October. We got a little bit of a break here, but not much. It is this little break right in here that we think maybe allowed the storms of the past week to form. But now, as you look at the forecast for the next week, another batch of easterly anomalies are forecast in the Kelvin wave generation area, likely shutting down the storm machine for at least a week. You get the sense right as you get to the end of the forecast window a week out here that maybe things will change again and that easterly anomalies will back off. Notice all the westerly anomalies here are over in the far, not even West Pacific, over the maritime continent or the eastern Indian Ocean. This is pretty typical of La Nina. That is, you get more easterly anomalies than normal in the Kelvin wave generation area, and westerly anomalies are all outside of the Pacific. During El Nino, this pattern reverses with easterly anomalies over here, westerly anomalies in the Kelvin wave generation area, and the North Pacific storm machine lights up. But that is not the case. We are in the rebound from a 2-year El Nino, and so it is not unexpected that La Nina and a tendency for the inactive phase of the MJO to be dominant at this point. Looking at the outgoing long-wave radiation models, another way to look at for the presence of the MJO. If you see blues, that means more cloud cover. That means less sunlight reflectivity off the ocean surface. That means the active phase of the MJO. But this is a very small blue patch here per the statistic model. It suggests a very, very weak active phase of the MJO, if at all. And you look 5 days out, 10 days out, nothing, it's dead neutral, and then 15 days out, well, a tendency towards the inactive phase of the MJO. You look at this, the GEFS ensemble model, it suggests a very, very weak active phase of the MJO, probably not strong enough to have any influence whatsoever. And then there are the phase diagram charts. So assume this is the North Pole of the North Pole of our planet looking down. The active phase of the MJO moves from west to east, from the Indian Ocean over the maritime continent, consider that Bali, New Guinea, over the dateline, over the West Pacific, over the U.S., into the Atlantic, over Africa, and back to the Indian Ocean. So the active phase makes a trek the whole way around the planet in about 6 weeks, and then the inactive phase follows it in the same 6 weeks period. Where the dot is where the active phase of the MJO is. If you're inside this circle, that's the sort of the circle of death, meaning that it's so weak that it has no influence whatsoever. The ECMS model says the active phase is very weak, incoherent, and not expected to do anything for the next 2 weeks. The GEFS model is a little bit more promising, suggesting that the active phase in a couple of days, about a week, might develop and pop out in the West Pacific and move to the east, but still pretty weak. If you're close to the circle, it's still very weak. If you're out in here, then it's strong. So kind of a mixed bag per this model. Then our final model for monitoring the MJO, the CFS model, again, measuring 850 millibar wind anomalies. That's up about 4,500 feet in the atmosphere, which is a good proxy for what's going on down at the surface. And if you actually look here, and the Kelvin wave generation area is right in this area right here. Same sort of chart, only past history is at the bottom, moving to the forecast in the future. We see westerly anomalies per this chart, but off at like 120 east. That's not even really in the Pacific. And easterly anomalies, this is this La Nina kind of pattern over the dateline right now. we can do this. And you see, in fact, we are supposed to be, the solid contour is the active phase of the MJO, but must be pretty weak if you have easterly anomalies running right through the middle of it. Anyway, come about the first week in November, we're supposed to go into the inactive phase of the MJO. Easterly anomalies maybe a little bit more pronounced, but east of the Kelvin wave generation area. In the main area that matters here, kind of a neutral pattern forecast. And then you go out past, let's say Thanksgiving. The long-range outlook says, well, just sort of a generally mixed pattern, maybe a tendency towards westerly anomalies. We suspect this is overstated. Easterly anomalies would be the expectation, or at least neutral anomalies if La Nina is in play. The models have been saying this would be stronger, and then as we get closer, it keeps getting weaker and weaker. So the thought is that this is probably overstated a bit, and we'll just have a neutral pattern pretty much going through into at least Christmas. So the MJO isn't suggesting any major enhancement or providing any fuel for storm development for the next couple of months. Let's take a look subsurface, see what's going on, and really see what La Nina is doing to the ocean. As you can see here, this is absolute water temperatures, West Pacific here, East Pacific here. These lines of X's are sensors on the TAO buoy arrays. Sensors as you go down 100 meters, 200 meters, that's 600 feet into the ocean or more. You can get a profile of water temperature from looking like this, and you can see warmer than normal temperatures in the West Pacific, and the warm water pool is very shallow in the East Pacific. This is pretty typical of La Nina. Actual anomalies, differences in normal for this time of year, you see again 1 degree anomalies in the West Pacific, -1 degree anomalies in the East Pacific, and even at the surface, kind of cooler than normal right here. Off Ecuador, a little pocket of normal temperatures or slightly warmer, but over the Central Pacific and at depth, cooler than normal, but not horribly so. This was actually down to -2, -3 degrees even 2 weeks ago. So it suggests that things have warmed up slightly, but it goes through these oscillations where it cools down, it warms up, it cools down. Some of that's fueled by the MJO, and some of it's just natural cycles. A high-res version of that same chart as of October 10th suggests the temperatures are a little bit cooler than what was stated in the previous chart, but this data is older. We suspect as it gets closer to, as we get closer to today's date, that in fact these temperatures will warm slightly. But still, this is clearly a La Nina period or a La Nina cycle or a pattern, really. Last year, it was all warmer than normal temps in here. That would be typical of El Nino. Now we're in the cool phase, and this is what you get. Upper ocean heat anomaly chart. This is the top 300 meters of the ocean. A sort of a way to look at what we were just seeing, but over time, you can see last year in November, Kelvin wave, much warmer than normal temperatures here. We're moving from the Central Pacific towards Ecuador. That was Kelvin wave number 5. Kelvin wave number 6 developed in February. Again, warmer than normal temperatures pushing from the dateline to the East Pacific. That was driven by westerly wind anomalies in the Kelvin wave generation area. And then you see all the cooler than normal water that was isolated to the far West Pacific. Then we got into the April time frame or so, and all that cool water starts rushing to the east. This was the onset of La Nina. And then as you see, that was a big push. Things have kind of mellowed out a little bit since then, but notice here we are in October. Cooler temperatures building a little bit, not markedly. I mean, this is not a strong La Nina by any stretch of the imagination, and that is actually a good thing, because normally when you have a strong El Nino, you get an equal and opposite reaction, that is a strong La Nina, but we've got basically a very, very weak La Nina in play right now. So next we look at surface, not subsurface, but surface sea temperature anomalies. If you were in a strong La Nina, you would expect to see much cooler than normal temperatures right here along Peru and Ecuador over the Galapagos Islands. Instead, we see actually warmer than normal temperatures by, what is that, a degree or 2 degrees even in pockets. Little pockets of cool water, but nothing too major until you get out to about 110 west and beyond, and that's where the core of the La Nina cool pool is, with temperatures, maybe 1.75 degrees below normal. But in the main area here, where you'd expect to see a lot of cooling and water pushing out, being driven by strong trades, you don't see any of it. It's pretty much neutral or even warmer than neutral. That is actually a good sign. And all the cool water is out here, meaning this is a westward displaced La Nina, sort of a Modoki La Nina, if you will. Here's the trend over the past 7 days. Just a little bit, a pocket of cool water off Ecuador here, but then warm, cool. It's this warm, cool, warm thing, oscillating anomaly. And then out here where the cool pool actually is, temperatures appear to be warming. We've been seeing this all since March, this oscillating warm, cool pool sort of thing. And actually, even last week, there was markedly warmer, a lot of warming going on in this area here. That has backed off some. So basically, if this is a La Nina, it suggests a very weak La Nina. Also notice here this cool pool, or temperatures cooling right in this area. That's a result of storm activity and upwelling that has been happening as of late, but is also somewhat indicative of the warm phase of the Pacific Decadal Oscillation, as long as there's warm water pooling up along the U.S. West Coast. Oh, and also notice this slight warming trend. This has been going on for a couple of weeks now off of Africa, working towards the Caribbean. Sometimes what you see is a pattern developing here first, and then it seems to migrate its way into the Pacific. We suggest that we're thinking that this warm activity here and this warming that's been going on here of the past 2 weeks has sort of also been tied with at least a slight pullback or demise in the inactive phase of the MJO, and that's what allowed the storm track to boost up the past 2 weeks. And then we zoom back, just sort of look at the high-level picture. Here is our La Nina cool pool right here. These are below normal temperatures at about 1.5 degrees in pockets. And then you notice over here, though, where if you were in a really strong La Nina, this should all be cool right in here. It's warmer than normal. So this is, again, why we're saying this is a westward placed La Nina. Also notice pretty warm off of Africa as well, and pretty warm along the U.S. West Coast. In fact, temperatures in San Francisco, ocean temperatures were 60 degrees, and that is cooking warm, especially. It's not that, during a El Nino year, that would be pretty normal. But for a La Nina year and to have 60 degrees temperatures off of San Francisco, pretty rare. We've talked about the Madden-Julian Oscillation. We've talked a little bit about La Nina. But let's see the impact of that in the atmosphere, because ultimately it's what's going on in the atmosphere. That's where storms are formed and the tendencies or the trends in the atmosphere. So we're looking at the Southern Oscillation Index, difference in pressures between Darwin, Australia, and Tahiti. This is an index. When it's positive, it suggests the inactive phase of the MJO. When it's positive for a long enough period of time, it can also suggest La Nina. For the past month, you can see definitely it has been in the positive state. Since October 10th, it started going negative, suggesting the inactive phase of the MJO for the past week or so. But, you need more than a week to do that. The current index value is 0.97, basically neutral. Here's the 30-day running average. It was 12.49 a month ago. It went up to 13.99, and now it's dropped down to 6.13. That sort of suggests the active phase of the MJO as well. And then the 90-day running average, this is mainly for looking at El Nino or La Nina, was 6.1 a month ago. It is now 7.69, suggesting a slowly rising index, suggesting, but not as high as it was here. Notice this, 8.42, but still suggesting that some weak flavor of La Nina is in control. Here is the 30-day average graphically marked out. Here is in January 2014 with this pulse here. This actually is the active phase of the MJO driving the Southern Oscillation Index negative. This was the start of El Nino, and we went through this steady downward trend into October of last year, and La Nina peaked out then. You can see the pulses. The downward pulses are the active phase of the MJO. The upward pulses, like here, are the inactive phase of the MJO. And then we got into, May of this year, massive inactive phase of the MJO. No real active phases. Another big one in the September, early October timeframe. Now, finally, a little bit of the active phase of the MJO. So note, we looked at some of the models. They're not really saying active or inactive phase. But when you look at this data, this is a good way of saying, yes, there is some sort of active phase of the MJO going on for the past 2 weeks. And that's why we're saying that's what drove the storm cycle and the storms pushing into California and swell. We got two significant class swells out of this pulse. One in Hawaii, I believe it was a week ago, and then another one into California a day or two ago. Of course, for the most part, it was all blown out in a mess, but still, significant class swell is big swell. Now, the question is, where is it going from here? Probably not going too deep would be our guess. It's not going to go down into negative territory, but it would be nice if it went a little bit deeper, but the models kind of suggest that's probably not the case. It's probably going to level off. And one other index, the ESPI index, instead of measuring difference in pressure between Darwin and Tahiti, this measures total precipitation in these two areas. When this index goes negative, that suggests La Nina, and it is pretty negative, minus 1.71. The lowest it was minus 1.77 about, that was a week and a half ago, so it's trying to rebound a little bit. The active phase of the MJO probably dampening it slightly. But still, this clearly suggests that we're in some sort of La Nina. It was in the plus 1.5 or 1.6 range when we were in the peak of El Nino. So anyway, this is just saying we've lost a lot of what El Nino had. Now, the interesting part was, and we've said this before, we thought that remnants from El Nino would continue in the upper atmosphere into about the Thanksgiving time frame or so, and we think that's still true. I mean, so just case in point, San Francisco got supposedly a bunch of rain during El Nino last year, but we actually got over 2 inches of rain in just generic San Francisco area in the past 4 days, which is a good amount of rain, very unheard of for this time of year. That from a extratropical system that was embedded in low pressure that was in the Gulf of Alaska. That helped dump a bunch of water on the state. But still, that's good. At least the northern part is getting wet. We think some of this is hangover from El Nino, but those effects will moderate and wash out as we get deeper into winter. You really don't get a sense of what the pure winter pattern is going to be like till you get to sometime past Thanksgiving into early December, maybe even mid-December, and then you kind of get a sense more of what's going on. So we're not going to hang our hat and say, oh, this is going to be a wet winter just based on this one rainstorm in Northern California, even though it was pretty good. Let's revisit that come late Thanksgiving. So to wrap this up, summarize what we've talked about right now, one more pulse of raw kind of wind swell stuff moving into California for Monday, and then a slow decline from there Tuesday, Wednesday, Thursday, drying pattern, less rain, less wind, things returning to normal. A little bit of energy for Hawaii too, but nothing to write home about. After that, unknown, but we suggest we're going to probably move into the inactive phase of the MJO, and the storm pattern will back off for a while. Of course, we are in La Nina right now, but we think the effects of La Nina are being dampened some by yet another oscillation that we talked about last week, the Pacific Decadal Oscillation. The thought is perhaps, and that's a 15 to 25-year cycle, we think we are moving out of what they call the cool phase of that, which has gone on since 98 through about the start of El Nino a year and a half ago. That maybe we're getting ready to go into a 20-year cycle of the warm phase of the PDO. That would support more storm development, more El Nino-like pattern, and more surf in general, and get us out of a drought in California. Unknown if we're there yet. It'll be quite a while, another year probably till we know for sure, but let's see how this winter goes. If this La Nina is rather muted, that would be one key piece of evidence supporting a change towards the warm phase of the PDO. Anyway, that's it for this week. We'll do it again next week, same time, same channel. Thanks for watching.